Today, as we work through this unit, we're going to be looking at the first section of Chapter 4, which deals with congruent figures. When I introduced this unit yesterday, I talked about how the focus is on triangles. In today's particular lesson, we will be seeing some other polygons other than triangles, looking just in very general terms what it means for figures to be congruent. And then we will focus again on specific looking at those triangles. So our objective today is to be able to recognize congruent figures and their corresponding parts. So if you open up the first piece of that flip book, have some information that you need to copy in there, so I will give you a minute to do that, and then we will talk about it. So when we talk about congruent figures, we've seen that word congruent before. Congruent figures. It says two geometric figures are congruent if they have exactly the same size and the same shape. Exactly the same size and the same shape. So when two figures are congruent, there is a correspondence between their angles and sides. So when we talk about that correspondence, when we look at the two triangles that we have up here, if I wanted to match those up so that I could see they were the same size and shape, take one and lay it on top of the other, I would need to just flip. I'd have to take triangle ABC and I would have to flip it over for those pieces to line up. Okay? So that's what they mean when they talk about this correspondence. So their corresponding angles then are the same size. They are congruent. The corresponding sides are also congruent. So if I took triangle ABC and flipped it over, okay, then A would match up with P, B would match up with Q, and C would match up with R. So those are the corresponding angles that we talk about. So down below, they've named those corresponding angles. Those corresponding angles are congruent. They're exactly the same size, the same measure. The same thing then happens with those sides. If I flip this triangle over, okay, I know that side AB matches up with side QP. BC matches up with QR. AC matches up with RP. So here we have two triangles. If two triangles are congruent, all three pair of corresponding angles would be congruent. All three pair of corresponding sides would be congruent. If I was working with another kind of polygon, for example, an octagon, all 8 pairs of angles would have to be congruent. All 8 pairs of sides would have to be congruent. So that's what it means for it to be congruent. They're exactly the same size and shape, which means their corresponding angles and sides all have to be congruent. So when you look at the next piece, congruent statements. Okay. When we're talking about congruency and comparing those two different shapes, in this example, two triangles, order is very important. So it says you must list you're going to write in corresponding vertices in the same order. So when I want to write a congruent statement that tells people that these two triangles are congruent, when I name the first triangle, I can use any order I want. What's important is that then the corresponding angles in the other triangle are in that same order. So this triangle on the left, if I named it in just alphabetic order, triangle ABC, I need to write the congruent statement for it. So it's congruent to triangle. What angle matches up with angle A in my other triangle? Q. What matches with B? B is P. And then C is R. Okay. If I used the first triangle, named it in a different order, and said BCA, then I need to change the order for my second piece. What matches up with B?
B.
P. With C?
R.
R. And with A? Q. Or again, if I did CAB, what matches up with C? R. What matches up with A? And then with B? P. So again, order doesn't matter when you name your first one. When you name the second triangle, you have to match up those corresponding vertices. Okay. And you must mark congruent parts in the diagram. And in that diagram that we were given, that had already been done for us. So if you have everything marked, then it made it easy to see how to match things up for those congruent statements. So in this example here, it says first to write a congruent statement. So the congruent statement is going to be naming the two triangles. So we have these three examples up above, but we're looking at those two different triangles. So again, the order for the first triangle does not matter. I'm just going to go alphabetic. So triangle ANT is congruent to triangle. What matches up with A?
BDO.
What matches up with A?
O.
O. What matches up with N? D. And what matches up with T? The B. Then it says to identify all pairs of congruent corresponding parts. So let's start out with the angles. So angle A is congruent to which angle? O. Angle N is congruent to D. Angle T is congruent to B. So two different ways you could find that. You could either look at the markings in the picture, or you could look at that congruent statement that we wrote and again match those corresponding parts in order. Now we need to do the same kind of thing with the sides. With the sides, I think it's easier to look at the picture and just use those tick marks. So if I start with the one tick mark, I have AT, that's a segment, so I need my segment bar across the top. If I switch the two letters around, that's okay. That matches up with BO, even though it doesn't look like it in the picture. We use those markings. Then I have side AN, which is congruent to side DO. And then I have side NT congruent to BD. So to be able to say that two triangles are congruent, we have to list all three pairs of corresponding angles, all three pairs of corresponding sides. Yes, Connor?
This might be kind of a dumb question, but so for example, like, can we say that like line AN is congruent to line DO, but then say like line BO is congruent to line AT? Like, do you know what I'm saying? Like, can we flip them around?
Oh, like flip this part around?
Yeah.
Yep.
Okay.
Yep. Since they're congruent to each other, yep, it doesn't matter which one's on the left, which one's on the right.
All right.
Okay. Next piece, we're going to take a look at some examples. Okay, so again, using what we just talked about, we want to find X and Y. Did I have everything from there? Yep, okay. So, this time we have two quadrilaterals, four-sided figures. They've given us a congruent statement. So again, that statement right there gives us all kinds of important information because of matching those corresponding parts. So first thing we need to do is mark all of that information in our picture. Okay, so angle D corresponds with angle S. Angle E, so I'm going to use two arcs for E and P. Q is 3 along with F. G is 4 along with R. And then we also have to mark our sides. Okay. Marking sides, I think, again, is easier if you look at your angle markings. So I'm putting one tick mark between 1 and 2. I'm putting 2 tick marks between 2 and 3. I'm putting 3 tick marks between 3 and 4. And then my fourth side gets the 4 tick marks. Okay. So this one, if I wanted to match those up, I would spin one of them around to get things to match up. So now that I know all of that information.
Interrupt you, I'm looking for sophomores. Sophomore flu shot. If you were a sophomore and needed your flu shot, now is the time to go down to the nurse's office, please. Sophomores to the nurse. Thanks.
What?
So, back to this. Now we need to be able to find X and Y. So when I'm looking at my pictures and looking for X and Y, I find them over in my second quadrilateral. Here's an X. This one's got an X and a Y. So I'm going to need to find X first. So in this right side quadrilateral, I have 2x minus 4. What does that match up with in my other quadrilateral? It's got the 3 tick marks, so it matches up with 12. So 2x minus 4 equals 12. So I add 4 to both sides. 2x equals 16. Divide both sides by 2. X equals 8. Then I also need to find the measure of y. So I know that 6y plus x is going to equal what?
68.
Huh? It's got the 3 arcs on it, so it matches up with angle F, which is 68. Okay? In place of the x, I substituted the value of 8. So I have 6y plus 8 equals 68. So I subtract 8. 6y equals 60. Divide by 6 to find that y is equal to 10. So again, when we have congruency statements, the order that we see in that congruency statement is very important because it gives us that information. In the next example, we want to show, so this is kind of like a proof. We need to be able to prove, we need to show that triangle PTS is congruent to triangle RTQ. So again, to be able to say that those two triangles are congruent, we have to show all three pairs of corresponding sides, all three pairs of corresponding angles. So when I look at my diagram, they've got my sides marked. Okay? So I know that when I'm looking at my sides, I know that side PS is congruent to side QR because of the markings. I know that side PT is congruent to side RT because of the markings. And I know that ST is congruent to QT because of the markings. So that was all given to us. Okay? We know that because it's marked in the picture. But then I also need to know that my corresponding angles are congruent. And I don't have any of that information marked in the picture. Okay? So I can't just say, well, it looks like it is. Okay? I need to be able to justify, to prove that I know angles are congruent, corresponding angles are congruent. So, what do I know? If I look at that diagram, any angle pairs that I know to be congruent? Using information we've learned. Simon, we need to wake up, please. Looking at that diagram.
Well, so when it says that triangle PTS is congruent to triangle RTQ,
Okay.
are those in specific orders right there, those letters?
So the letters are in order, but we need to show. So we need to figure out, okay, if we're looking at order, we need to figure out how do I know that P and R are congruent.
And we can't say it's because that's what's given.
Right, we can't say because of that, because they want us to show that this is true. Okay, so we're kind of trying to prove. Okay? So we need to show, figure out how we know that angles P and R would be congruent. We need to show that the two angles that have the T's are congruent. And then we would have to show that S and Q are congruent. We can do that using things we've learned so far this year. What about the two angles that have the vertex of T? How do we know they're congruent? What kind of angles are they? Vertical angles. So I know angle PTS is congruent to angle QTR because they're vertical angles. Okay. So I'm going to mark those angles to be congruent. My other two angle pairs. I'm looking at this picture. Something that I noticed in the diagram that I haven't used yet are these arrowheads. What's the purpose of those arrowheads? Very good. The lines are parallel. So I have parallel lines. And if I look at one of my other lines, I can say this yellow line is a transversal. So how does that help me? If I have parallel lines cut by a transversal.
Now, if I could interrupt you again, we need the freshmen. The freshman students that are to take the flu shot, please report to the nurse's office. Freshman flu shot, nurse's office. Thank you.
So we just did a street map project with parallel lines cut by transversals. So if I have parallel lines and this yellow line is my transversal, what do I know to be true?
P and R alternate exterior.
Okay. Angle P and angle R are congruent because they are alternate interior angles. They're in between the parallel lines. Okay. If we rotated this, they're inside of the parallel lines. Exterior would be outside of the parallel lines. So P and R are alternate interior angles. If I did the same thing with the other transversal, then I know that S and Q are congruent because they are alternate interior angles. So again, to be able to say that something, that shapes are congruent, we have to know that all three pairs of sides are congruent, all three pairs of angles are congruent. One more thing that I want to talk about. You will want to write this down somewhere on that page, whether it's up at the top, down below, because it is something now that you will be able to use when we look at proofs. It's called the third angles theorem, and if we think about it, it logically makes sense. It says if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. And this comes directly from our angle sum theorem that we talked about yesterday, because three angles in a triangle are always going to add up to 180. So if angles A and D are the same measure, let's just make up something. Let's say they're 60. Okay, so these angles are both 60. Okay, we know that angles B and E are congruent. Let's say they're 45. Using our triangle angle sum theorem, how much does angle C have to equal? Come on, guys. How much does angle C have to equal in our triangle?
75.
75.
Nice.
If I look at triangle EDF, how much does angle F have to be?
75.
75. Okay. Angle C and F are congruent. Okay. So even if they only give you two pairs, you know two pair of angles are congruent, the third pair of angles must be congruent. So that's what we call the third angles theorem. So that's something, again, that we can now use in proof. which will be important to us as we spend a lot of time with proof in this unit.